Good morning. Today we are covering right triangle congruence. This is lesson 6.6 in geometry, and I have an HL here because the shortcut name for right triangle congruence is HL, or hypotenuse leg congruence, as we shall see. So what are we going to do? You're going to, by the time you're done, be able to recognize and prove the shortcut congruence for right triangles. So we're going to prove that two right triangles are congruent if the hypotenuse and a leg of the first right triangle are congruent to the hypotenuse of the second right triangle. Okay? So this is going to support Geometry IXL Skill K11. All right, and remember that you must take notes on this, and please make sure that you include with your notes this following header if you're going to get full credit, full first and last name, no abbreviations, no aliases, and make sure it's clear. And then please, when you are done with your notes, upload your video. You have, upload your notes to me. You have until 11:59 p.m. on Saturday to do so. You can upload them to either the Student View Dropbox, or you can email them to me as we normally do. Okay, so let's do just a little bit of review here. In this unit, we have finding shortcuts. That's what we've been doing here. Let me get my red pen here. That's helpful. Shortcuts to determine whether two triangles are congruent. We're looking for triangle congruency. And initially what we found was that so long as the corresponding angles and the corresponding sides of two triangles are congruent, then the two triangles themselves are congruent. Okay, so we found the following shortcuts, though. So if you look at, before we even talk about shortcuts, we found that so long as the corresponding angles and sides of both triangles are congruent, then the two triangles are congruent. That means you're looking at three angles plus three sides times 2. And so 3 plus 3 is 6 times 2 is 12. So we were looking at 12 corresponding parts. Okay? So it's nice in geometry if you can discover shortcuts. And the ancients, when they worked this stuff and after they proved, they started to notice that they could still show congruency even with the shortcuts that they observed and recorded here. So we have already gone over the following shortcuts. Side congruence. So it's been found that the corresponding sides of two triangles, if they're congruent, then the triangles are congruent. Then we have side angle side congruence, and that is where you have corresponding side and included angle and another corresponding side of two triangles. If you find those things, then the two triangles are congruent. Side angle congruence, same thing. An angle in this case, though, with an included side and another angle, if you find those in two triangles and they're congruent, the angle, the side, and the angle, then the triangles are congruent. And lastly, we found that if you found that corresponding angle and side of two triangles are congruent, then the triangles are congruent. You don't have to go through all 12 corresponding parts in those cases. Saves time. So, these guys were out building, these ancients, they were out building palaces and castles and temples and all that kind of thing on a grand scale, and the people that worked under them, they needed shortcuts. This was kind of how all this developed. It just was a practical thing. So, so long as those corresponding parts were found congruent, then the two triangles would be congruent. All right. So now we also found, let me put something over this for the moment. We also found something else. If you're doing shortcut with these triangles and only proving that certain parts of the two triangles are congruent, what about the parts that you didn't talk about? Well, think about it. Bottom line is, if the shortcuts determine the triangles are congruent, then all the other parts have to be congruent to their corresponding partner parts. So this particular concept was developed. Corresponding parts of triangles not mentioned in the above shortcuts were also congruent under the rule C, P, C, T, C, which means corresponding parts of congruent triangles are congruent. This is a huge, huge shortcut for people. Very important. Huge shortcut. Used a lot. Okay? All right. So now we come to what we're going to do today. So the shortcut known as hypotenuse leg or right triangle congruency. So here it is. What it says is if you have two right triangles, and if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So let's just circle this. A hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of a second triangle, then the two triangles are congruent. So look at these two triangles, ABC, DEF. So over here, BC, that is a leg. BC is congruent to EF. Now it's shown here, and it's also shown here. This is basically something you would see in a given, but oftentimes you see it as this in a drawing, or you may see both of these things. So it's important when you, I tell you about, I want to do this in tests. Draw this stuff out. Draw whatever the given is into it. So if they just give you two blank triangles and then they give you this information in writing over on the left, please transfer it over to here. And then you see what's going on. And you can then make some conclusions from it. So, okay, they said if B is congruent, BC is congruent to EF, and then AC, which is the hypotenuse of this triangle, is congruent to DF, then triangle ABC is congruent to triangle DEF, these two triangles. Now, you're saying to yourself, well, how could it be with just two legs? Well, remember, this only applies to right triangles. These have to both be right triangles. So they told you that already. Consider that part of your given. So really, you've got a side, an angle, or an angle, side, congruence. But this applies only to right triangles. So don't at this point in time make the assumption on your own that there is something called angle, side congruence with other types of triangles. It may be, may not be. This is the thing about geometry. You don't know until you are given the rule. So you haven't been given a rule about those, but you have been this one. So this is pretty much it. Okay. Now, this is the last of what we're looking for in this unit. Now, we're going to be applying the stuff to other units. So we'll see what happens as we go. Keeping it open for you. All right. So that's the rule. And we're obviously going to need to apply this rule, and we're going to do so in this proof here. So this is a we're going to do this as a paragraph proof, and it's also kind of one of these word problem kinds of things that I pulled. And the picture is never the greatest, but I'm going to enlarge the picture for you, and I'm also going to get a visual aid if I can find it. Here it is. To show you what's going on. So let me first enlarge this. Let's see here. Okay. So if we enlarge this, you can see the picture. I'm going to kind of bring it over here so you can see everything. So it says that the television antenna is perpendicular to the plane containing points B, C, and D. So here's the television antenna, and the points that they're talking about are B, C, and D. Now they are not very clear, so I'm going to try to rewrite them here. So this is B, this is C, this is D, and this one down here is called E. A up above is clear. All right, so now you can see this. And so obviously the antenna is perpendicular to the ground. That's telling you something. So that perpendicular there, perpendicular means it's at a right angle. And so right angle, oh yeah, 90 degrees. So there's a 90-degree angle in this, okay? And where's it got to be? Well, perpendicular to the ground, it's out where E is. So from A to E to D, that's an angle. It's got to be a right angle. From A to E to C is also a right angle. And from A to E to B is also a right angle. So, recognize again that, and I'll show you with my little visual, that what you've got is a depiction in 2 dimensions of the 3-dimensional figure. And there really are 3 triangles there. So, all right. So then it says here, each of the stays running from the top of the antenna to B, C, and D uses the same length of cable. Well, stays, what on earth is that? Well, what it is these, you've probably seen this with towers like this. They have a narrow base at the bottom. And so, to keep them from being blown over by the wind, you have these cables that run from the top of the tower out to a certain distance, and they always have them go out to the same distance, although they don't say that here, so we can't use that as any kind of a proof. But we do know, it says here, that B, C, and D, that this cable is the same length. That's what it says. So the cable is the same length. So that means then that the cable from A to D here is the same length as the cable from A to B, even though it doesn't look like it in this 3-dimensional figure, and from A to C. All those cables are the same length. All right? Now, they want you to prove that triangle AEB, AEC, and AED are congruent. So all 3 triangles, here they are down here. Now, this is sort of belts and suspenders, and I'm going to, now that I've shown the picture, I'm going to go back to, let's see here, go back to the smaller picture here so we can see more. The information is repeated here. It says AE, so let's find AE. AE is perpendicular to EB, so it's perpendicular here. That's a 90-degree angle. So 90-degree angle. AE is perpendicular to EC. AE is perpendicular to EC, so that's another 90-degree angle. All right? And then it says AE is again perpendicular to ED. ED is this one here. That's another 90-degree angle. So we have 3 90-degree angles. Then they tell you AB is congruent. AB, that's this cable, is congruent to AC, which is this cable, and it's congruent to AD, which is this cable here. So all the cables are congruent. The angles are congruent. All right? And then they want you to prove that the triangle is congruent. So we're going to do this as a paragraph proof. And so before we do that, though, last thing, and I was going to show you the visual, so you just better understand the picture. And so here I can do it at least with two triangles. So if I were to put them together like this, so here they are flat, right? But if you were to put them together like this, you can see that, you know, it's kind of like a Christmas tree, one of those fake Christmas trees that you see sometimes. So you've got two pieces here, and then you've got another one over here. And that's basically what's going on. So all of these should be congruent if we can prove it. All right? Okay, so now what I want to do is I want to write what the given is telling me, and then let me just move this over here a little bit so that I can do this comfortably. And then what it's basically, what's the proof for it. So here's a paragraph proof. I'm just going to write paragraph proof. All right. So first of all, you're given that AE is perpendicular to AB and AE to EC. So let's just do that. You are given that AE is congruent to EB. I'm sorry, not congruent. I misspoke. Perpendicular to EB. Right? And AE is perpendicular to EC. Now I'm going to play a little trick on you, only because the proof that I took this from played the same trick. They don't go on and talk about AE is congruent to ED in this. Now part of it is that you can run out of space easily with these things. But it's left off, and it's left off intentionally. Okay, so that's the proof, or I'm sorry, the given, basically. Right, because it said given here. So then we go on to say which implies that I muff up on these things, that triangle AEC and triangle AEB are right triangles. Okay, so that was basically the proof. So I'm going to put a little one here, proof. So this is the one, the first part of the first given. This is the first proof. All right, so we go on and to, what's my next given? Oh, I didn't finish this. They're right triangles, so you want the proof part of it nailed down. So, and by definition, so or just by definition, triangle AEB and AEC are right triangles. Okay, so now you've got the proof, the full proof. Okay, so now Let's go on to the second. So number 2. You are given that the hypotenuse of these two triangles, right, AB and AC, are congruent. We are given that information that they're congruent. So you are given, maybe I should put given in red. So given, that's the given, that the hypotenuse of the two triangles, sometimes I have to erase, of the two triangles AB and AC, as this is line segment AB and line segment AC. And remember, you know, here's AB, here's AC. Those function as the hypotenuse. So AB and AC are congruent. That was given to us, right? Okay. So that was just given information. And we were also given that AE is congruent to AE. This is sort of a run-on. AE is congruent to AE. Okay. Oh, I know what I did wrong here. So let's erase this. Got my thought tumbled. Okay, so let's put a period on this. That was the end of this. So we're also given, let's just do it down here. So also, this is, we'll call this 3. Also, AE is a leg belonging to both of the triangles. Right? AE is a leg that belongs to both of these two triangles, and actually belongs to all 3. Okay. So now we can say this is our proof. So AE is congruent to AE by the reflexive property of congruence. There we go, that's much better. Okay. Okay, so now we come up with our conclusion. We've just talked about congruent hypotenuse, right? And then AE is this leg. It's the leg for all 3 of these. So we've got hypotenuse and a leg. And we also said these are right triangles, right? So here's a right triangle. We know that we have a hypotenuse, right? And we also have a leg. So hypotenuse, a leg, and a right triangle, a right angle rather. We conclude, therefore, triangles AEB, or why don't we just say triangle AEB and triangle AEC are congruent by the hypotenuse leg theorem. And if you remember, that's called hypotenuse leg. Right? You can shorten it to that. All right. Now, last thing. Let's move this over so you can see it all. The last thing is that third triangle, AED. It was purposely left out. Now, why? I suppose you could say, well, because it just would have been a lot more words here. We would be off the page maybe slightly. So, but what we can say is, well, look, if triangle AEB is congruent to triangle AEC, triangle AEB is also congruent to triangle AED. So, you want to also add triangle AEB is congruent to triangle AEC, which is congruent to triangle AED by the transitive property of congruence. Because that's the transitive property, what we were showing up there. Transitive property of congruence. Okay. All right. The thing you could say, possibly, is corresponding parts of congruent triangles are congruent. Right? Because these are all corresponding parts of congruent triangles, are they not? So we could have said, well, okay, well, the third triangle fits the bill too. It shares the same leg and the same angle and the same length of the side, so it fits the bill. So that's basically it. No muss, no fuss. We're done, and I will let you go. Have a wonderful day. Take care now.